Okay, so this is the last part of the Metamorphic Petrology review. Um, First, we need to talk about the protolith. So I kept mentioning for you difference between bellites and basalts. And as you've seen, yung mineralogy ng metamorphic rocks will be different for these two rock groups pa lang. So of course, you can imagine there are many rock types, many different bulk compositions. For example, limestones, they will also exhibit different mineral assemblages compared to the ones that we've discussed before. Ultramafic rocks, ganun din, etc., etc. So yung rock type natin or yung protolith natin will determine the chemical composition ng metamorphic rock natin. So it's very important in deciphering the protolith. And the reverse is true. If you have a metamorphic rock, you can infer kung ano yung protolith niya based on the mineral assemblage that you have. For example, when you have a marble, most likely yung kanyang protolith is a calc-silicate, a limestone, for example. Dito din pumapasok yung ilang prefixes like ortho and para. Orthonise or orthoschists means that this rock is of igneous origin, whereas paranise or paraschist tells us that the rock was derived from a sedimentary material. Okay, so the chemical makeup, aside from controlling yung bulk composition ng ating metamorphic rock, chemical makeup of the parent rock or protolith will also determine the degree of metamorphic change or the degree of change that a metamorphic agent will cause. For example, a granite may be metamorphosed by a basaltic magma, but a gabbro will experience less degree of metamorphism kasi parehas sila ng composition, parehas sila ng temperature. Okay? Yeah, so these are the 6 main groups ng bulk composition roughly. So we can group all the rock types into these 6 typical or broader groups ng bulk composition. So ultramafic rocks usually found as are usually the mantle rocks. Of course, hindi kasama dito yung kasama rin dito yung mga ultramilonite na volcanic rocks, yung mga sorry. Yung mga tsaka lumata pa. What's my term? Yung mga kumatiites. So yung mga kumatiites are also ultramafic in composition, so they have the same bulk. Okay, so we don't basically when we talk of these bulk compositions, we don't necessarily we should not limit ourselves to the origin itong mga batong to. Kasi for example, a mafic rock may be a basalt or a gabbro, pero it may be sedimentary in origin, but the same essentially composition, iron, magnesium, and calcium. So basically, if you have sedimentary, basically a volcaniclastic, essentially. So if you have volcaniclastic rocks or sedimentary rocks whose clasts are mostly derived from basalts and gabbros, if you metamorphose the two, you will have the same mineralogy, essentially. One will be orthoschist, for example, or orthonise, the other being paranise or paraschist, which is sedimentary in origin. Yeah. Shales and mudstones, when we say shales and mudstones, these are collectively referred to as bellites. This refers to continent-derived shales and mudstones. They are characteristically high in aluminum and potassium and silica and low in calcium. Okay? Carbonates, on the other hand, includes limestones, dollostones, but also calc-silicates. Actually, the more pure yung ating protolith, meaning limestones and dollostones, the less changes or variations in the minerals we expect. So a pure limestone, for example, that only contains calcium carbonate, magbabago-bago lang yung crystal phase niya between calcite and aragonite, calcite and aragonite. But if you add magnesium sa mixture, pwede siya minsan mag-develop ng olivine, pwede siya mag-develop, for example, ng diopside. So these mixtures, syempre, this requires SiO2 din. So dapat yun yung mga calc silicates. So calc, meaning may carbonate ka, silicates, dapat meron ka rin SiO2 and other components. So these are referred to usually as impure carbonates. So you can think of calcsilicates as the calcary sandstones, calcary mudstones. Okay, so lahat yon are grouped as carbonates. And then quartz rocks are church essentially, ganun din, since this is basically as silica. Some contain a bit of a little of other components like iron, so but mostly quartz. So ganun din, boring lang din yung changes sa mineral assemblage niya. Puro quartz lang siya. Nagbabago-bago lang yung phases ng quartz. I mean, yung stable phases ng quartz. Pwede siya minsan quartz, pwede siyang stishovite kapag high temperature, pwede siyang coesite kapag high pressure, etc. Quartz-feldspathic rocks are typically referred to as samites. Again, this is the quartz-feldspathic rocks, maybe the granitic or tonalitic intrusions, typical in continental setting, or they may be arcosic sandstones, again also typical of continental setting. So yun yung nire-refer natin as quartz-feldspathic rocks. And these rocks, they have also high aluminum, but not as high as pelites. And they are also poor in calcium. But ang mas significant sa kanilang mataas is yung silica. So quartz rich, basically. Yeah. So kanina, I kept mentioning, I think napakita ko na rin siya before, but in a different way, yung mga photomicrographs ng different phase sheets. This is the metamorphic grades that we know, and it basically shows in different, these names basically represent the different mineral assemblages, progression of mineral assemblages as you go from this low temperature side to the high temperature side. And then ito naman kapag pelitic yung protolith mo, but the conditions are the same. For example, 800 degrees Celsius, what you have for metapelite would be garnet, cordierite, sillimanite, K-spar. Whereas on the other hand, kapag 800 na mafic rock naman yung metamorphose, you will have a pyroxene granulite, meaning clinopyroxene, an orthopyroxene, and a plagioclase essentially. Yeah, so yun yung importance ng protolith. Controls yung mineralogy ng ating metamorphic rock. So, question, among these parameters, which is not used in naming the last part, classification of metamorphic rocks. So, as an intro to that, among these parameters, which is not used in naming metamorphic rocks, A, presence or absence of foliation, B, foliation, protolith composition, C, type of metamorphism preserved, or D, retrograde mineral assemblage. The answer to that, again, you can pause at this stage, then just play it again kapag may hula na kayo. And the answer to that is D, retrograde mineral assemblage. Although mineral assemblage is used in naming, it's the prograde assemblage that is preferred unless retrograde process is to be highlighted. So when we say quartz biotite schist, possibly actually na may muscovite yung quartz biotite schist natin, but if we think that the muscovite is retrograde, or we can see that the muscovite is replacing the biotite and is therefore retrograde, then pwede nating tanggalin sa pangalan yung muscovite. Okay? So, naming of metamorphic rocks is quite simple actually. It's based on this book by Fetz and Desmonds. This is the recommendations of the International Union of Geological Sciences, subcommission on the systematics of metamorphic rocks. So, my basis actually in naming ng metamorphic rocks. Simple lang siya. It's basically just like igneous rocks using texture and composition. But unlike igneous rocks, it's more simple and flexible. You basically have a root name, and then you can add modifiers, you can add textures or mineral aspects depending on how you what needs to be highlighted. Okay? So this flowchart, basically, pag binasa nyo to, ito na yung entire classification ng bato. But it can be with, of course, with these parameters, and it can be summarized this way. So ito yung mga GL1, GL2, GL3. I refer you to this book by Fitz and Desmonds if you want to learn more. Pero simple lang siya actually. Ganito lang siya. So there are 4 questions essentially that you have to answer. 1, if only slightly metamorphosed yung ating bato, you just add the protolith meta you just add the prefix rather, the prefix meta to the protolith name. So for example, a meta-conglomerate means slightly metamorphosed na conglomerate. And you can still identify the conglomeratic na protolith. So ano yung itsura ng meta-conglomerate? Posibleng deformed na yung clasts mo. They nag-exhibit na ng foliation yung matrix ng ating conglomerate. So that's meta-conglomerate. Metabasalt, for example, yung yung mga pillow lavas, it's obvious na pillow lavas siya originally and medyo na hydrothermally altered lang siya. So you can refer to that as metabasalts. Next question is, so yun yung meta plus protolith name. Next question is, kung metamorphic na talaga siya, di mo na ma-identify yung protolith. Next question, is it a high-strain rock or not? Meaning, kung high-strain rock siya, is it related to a fault zone? So kung related siya sa fault zone, mamaya may separate naming. But if not related to fault zone, is it foliated or lineated? If yes, if it's foliated and lineated pero hindi related to fault zones, then you can just refer to it as either slate, phyllite, schist, and gneiss. Slate yung lowest foliation type, so this is basically rock cleavage pa lang. Ganun din yung phyllite, pero medyo mas meron ka ng phyllosilicates or sheet silicates rather, hindi naman necessarily phyllosilicates. Hindi pala ni sheet silicates. Other minerals that exhibits foliation. Okay? So, yun yung phyllite na, but it's not yet coarse grain. Schist kapag coarse grain na, and then gneiss when you have banding. Kapag wala namang foliation, then it's non-foliated metamorphic rock, and you can refer to it simply as granophyls. So all non-foliated metamorphic rocks, you can refer to them actually as granophyls. However, itong question number 2 is trumped by specific rock names. So dito, I guess, medyo nahihirapan iba kasi you have to remember yung specific rock names. But number 2 is there always. So you can simply call it as schist or you can simply call it as gneiss kung di mo maalala yung specific rock names. Both are accepted. Okay? And then number 4, you can just add modifiers. So for example, from number 2, you already identified the rock as a schist. And then you want to highlight that this particular schist contains staurolite and kyanite. So you can refer to it as staurolite kyanite schist. If this is a specific rock name, hornfels, so it's a granophyll, non-foliated, na granophyllsic na metapelite. So non-foliated metapelite, we have a special name for that, hornfels. Okay? So if you want to, for example, to further highlight na itong specific hornfels na to contains andalusite, and this andalusite occurs as a porphyroblast, you can call the rock andalusite spotted hornfels. So kaya nga siya naging complicated tingnan because you can add mineral or textural modifiers. But actually, number 2 is just ito lang yung minimum requirement basically when naming the metamorphic rock. Unless, of course, high strain or fault related yung bato mo, then we'll have to wait for that. So ito muna. Ito muna tayo sa step 2, tsaka sa step 3. So if you have foliations like this, for example, based on the, you can identify foliation directions as, foliation directions are usually referred to as schistosity directions. So S1, for example, is this plane here, itong foliation directions na horizontal. And then if this foliation direction means na yung, since it's foliation is this way, then it means compression was this way, D1. Okay? However, if, for example, nagbago yung stress direction, you have D2, then it will start forming this cleavage planes, or this is also foliation, of course, this new foliation direction, which you can refer to as S2. But since no new minerals grow along these cleavage traces, we know na itong deformation D2 stage is not as intense as D1, kumbaga. Okay? Kaya hindi pa nasisira basically yung older foliation na S1. How about relic structures, kunwari bedding plates? You refer to that, we refer to that as S0 or S0. So bedding plane, for example, which is parallel to S1, so S0 lang siya. And then if you have lineations like this, especially elongation lineation, so if you have minerals that are elongated and aligned in a specific manner, then that is lineation, and we usually mark them as L. So L1, L2, L3, depending on the stage. So you can have a schistosity 1 and at the same time an L1, uh, uh, lineation, intersection lineation L1. Yeah. Dito rin makikita yung difference between foliation and lineation. So foliation is this arrangement of minerals like this, okay, along the sides. Yung planes representing yung uh, arrangement ng ating minerals. If yung elongate minerals are aligned in a specific direction, okay, as seen from the foliation surface, itong surface na to, then that is the time that you can identify it as lineation. So here, you cannot identify this as lineation. You can only, this is foliation. Identify the foliation, or rather, identify the lineation along the foliation plane. Okay? So, yun siya. So, ito yung two. So, foliation and lineation, these are planar and linear fabrics in the rock. Usually, yung foliation represents the DPO or the dimensional preferred orientation of platy minerals, not just phyllosilicates, but typically phyllosilicates. But in some cases, pwede siya actually hindi obvious sa mineral arrangement, but rather sa lattice preferred orientation ng mga minerals natin. This is especially true for monomineralic rocks. So, mga rocks that is composed of a single type of mineral like olivine, like dunite, which is composed only of olivine, quartzites composed only of quartz, o kaya marble, which is typically composed only of calcite. So these minerals, kahit na compression yung dominant cause or agent of metamorphism nila, pwede sila actually hindi magpakita ng dimensional preferred orientation, kaya lagi natin sinasabi na non-foliated sila, but that's not actually true. If we look at their crystallographic elements, they may actually exhibit lattice preferred orientation, and that is also a type of foliation. Okay? So, basically yung sinasabi ko ay not all marbles are non-foliated. You have to check yung lattice preferred orientation din kung meron or wala. Okay, so foliation types in order of increasing grade. Yung sinasabi ko kanina, cleavage kapag tendency to split pa lang along subparallel planes. Pag platy na yung phyllosilicates, but are too fine-grained, then that is cleavage lang. Kapag schistosity, meron ka ng dimensional preferred orientation ng platy minerals or inequant mineral grains. So in the case of amphibolites, this may be not necessarily a phyllosilicate, so this may be amphiboles, for example, exhibiting yung ating DPO. And then, when you have poor schistosity, and instead what you have are segregation of layers, then that is a gneiss foliation type. So, dito nagmumula yung naming natin as slate, phyllite, schist, and gneiss. This only reflects yung increasing degree of foliation. This is not always, and although this sequence of slate, phyllite, schist, and gneiss generally reflect an increasing temperature, yung increasing grain size na yun is not always a function of temperature. As we mentioned before, pwedeng deformed yung schist natin, so that in terms of mineralogy, it's actually much higher grade. Kaya siya phyllite, for example. Kaya siya sorry. One more thing. One more time. So, kunwari, if you have a schist, tapos na-deform siya so that it became more fine-grained, kung pa siyang phyllite, pero pagdating sa mineralogy, kunwari, meron siyang puro pyroxene siya. May pyroxenes, pyroxenes, and plagioclase. So that indicates a granulite phase, granulite grade, diba? Granulite grade. Mas higher grade pa rin yun, and therefore mas mataas yung temperature niya compared to a schist, for example, that is composed only of amphibole and plagioclase. Amphibolite facies yun. So, yun yung yun yung evidence na although a schist, this sequence, late phyllite schist and gneiss, is generally reflective of increasing temperature. Please use this only as descriptive descriptive classification scheme. It's not always a useful way of metamorphic grade approximation. Okay? Metamorphic grade approximation should always be done based on mineral assemblage, not just degree of foliation. Okay? So, yeah. Well, laging tinuturo sa atin, slate, phyllite, schistosite, tapos highest grade yung gneiss, laging lowest grade yung slate. Phyllite, that's not always the case. This is an example. So here you have a staurolite chloride schist, chloride mica schist, and this is a lower green schist granite gneiss. So this is a gneiss. This is a staurolite chloride schist. Both are all roughly of the same metamorphic grade, but this is a gneiss and this is a schist. So, diba? Iba siya. Ito naman, for example, here you have a spinel sillimanite biotype garnet gneiss. This is sillimanite. So, definitely, yung Barovian series kanina, nasa sillimanite isograd na tayo sa gneiss. And in this particular case, it's higher grade compared to this staurolite chloride mica schist. So, yun yung sinasabi ko na always base yung metamorphic grade estimation on the mineral assemblage, not on the foliation grade. D looks like a foliation, looks like a foliated rock, but this is very fine grain. And based on study, this is actually a mylonite. And E and F are amphibolite facies. And amphibolite facies orthonized, so igneous origin, with granite veins, puti-puti, with granite veins. And then F is an amphibolite facies banded and folded marble. Yeah. Ano ba? So non-foliated and the isotropic rock. No, so pag non-foliated, non-strained rock, and walang foliation, so you can refer to that as a granophyllous. Take note, granophyllous is not the same as granulite. Granulite is the facies. Granophyllous just means no non-foliated metamorphic rock. May special names tayo, like hornfells for a granophyllosic metapelite, marble for a granophyllosic meta limestone or meta dolostone, and quartzite kapag meron kang granophyllosic na quartzite. So these are specific rock names with genetic meaning, but technically they fall under granophyll. So these are examples. For example, these are examples na granophyllous. Yeah, granophyllosic texture. So again, this is typical of contact metamorphism. Then again, so either granophyll, slag, fillet, schist, and gneiss, or kaya granophyllous. But then again, these names are trumped by special names. There are specific rock names. So specific rock names, if you know them, you should use them instead of the step 2 sa naming. So if it's predominantly calcite or dolomite, you can just call it marble, foliated man or non-foliated. If it's predominantly quartz, it's quartzite, foliated or non-foliated. If it's low-grade mineral with chlorite, actinolite, epidote, and albite, it's referred to as green schist or greenstone. So green schist is not just a facies, it's actually the rock name then. The same is true for blue schist. So a blue schist is a rock which contains blue amphibole, not necessarily glaucophane. This may be rivicite, ricterite, blue. Yeah. And maybe it may be used even for granophyllous. So granophyllosic, meaning non-foliated na blue schist, is a thing. And at the same time, pwede rin tawaging glaucophane schist kapag ka foliated na glaucophane block vein bearing rock siya, na itong bluish rock na to. So blue schist siya. Since it's foliated, you can also call it as glaucophane schist. So yun yung sinasabi ko na medyo madali yung naming. Medyo flexible yung naming. Metamorphic rocks as recommended by the IUGS, by this one. So if you want to learn more, then siya. Okay? Okay. So pa. Okay, sorry. That, nag-skip ako ng D and E. D is amphibolite. Amphibolite is schistose or granophysic na rock which contains or which is composed predominantly of hornblende and plagioclase. And then serpentinite kapag metamorphosed. Specifically, serpentine na lang yung makikita natin. Dominantly, serpentine na lang makikita natin na mineral, which usually is, or which is usually the product of the metamorphism of peritocides, hydrothermal metamorphism of peritocides. Eclogite is reserved for an omphacite garnet rock. Dapat walang plagioclase, and instead aluminum nung sa plagioclase is transferred to garnet, or it is used to create garnet and CPX. So yung CPX na opposite niya. Calc-silicate rocks, either granophyls or schist. This refers to impure limestones, so calcium, magnesium, iron, aluminum silicates. Skarn or tactite is reserved for contact metamorphosed calc-silicates. Okay. And then granulite is hydrate metapelite or mafic hydroxyl-free minerals except biotite, and in these rocks, plagioclase and orthopyroxenes are common. Pegmatites are composite rocks, composite meaning mixtures of leucosomes, which are usually the melt segregates, and melanosomes, which represents could have been the rest type melting, but not necessarily always true. Okay, but it looks like this. So you have here this felsic bodies, some evidence suggests na ito ay actually melt pockets essentially. Although whether they are in situ or transported a little bit is not always clear. I mean, needs further investigation. And then again, as mentioned, you can also add modifying terms. So these modifying terms are used to provide additional information on the nature of the rock, the mineralogy, the structure, the properties, and the chemical composition, as well as metamorphic grade ng bato natin. So for example, if the rock is lineated, layered, or banded, or folded. In terms of mineralogy, you can refer to the porphyroblasts as porphyroblastic texture. Take note lang na kapag may porphyroblast, dapat yun ay newly grown, larger mineral compared to others. So a kyanite porphyroblast schist means na dominant yung malalaki yung kyanite niya, and sure ka na yung kyanite na yun is a porphyroblast, not a porphyroblast. Some low-grade rocks can also occur as ovoid spots. So you can have, for example, the spotted phyllite, or meron pa rin, for example, ogen, which translates to eye-shaped grains, porphyroblasts usually, or porphyroclasts rather, porphyroclasts. And these are, you can name the rock that contains them, ogenlites, for example, pyroxene ogenlites. Yeah, and then yung minention ko kanina, ortho or para, ortho for igneous protoliths, and para for sedimentary protoliths. So for example, orthonise, paranise, or orthoamphibolite. The mineralogy or metamorphic grade or conditions, you can also convey that sa rock naming. But usually, not so much. So mineral content modifiers, when they are rare, conveys a specific bulk composition or indicates metamorphic grade. So you list them in order of increasing abundance. Okay? And then ito yung kaninang iniskipan natin, yung high strain rocks. So pag high strain rocks, basically ito yung name niya. Yung questions, parang may next set of questions lang siya. Does it exhibit cohesion or not? If it does not exhibit cohesion, meaning hindi pa siya pato talaga, hindi pa siya, hindi pa to eh. Hindi siya lithification. Cohesion means solid na siya. Kapag nagbibiyak-biyak pa siya, basically, you can just name it as either fault breccia kapag mas marami yung class kesa matrix, or fault gouge kapag more than 70% yung matrix mo, fine-grained material. If it exhibits foliation, or not foliation, if it exhibits cohesion, is it foliated or non-foliated? Kung foliated siya, you can refer to it as either protomyelinite, myelinite, or ultramyelinite, depending on the percent matrix that's present. So protomyelinite contains the most amount of porphyroplast, less pa yung matrix, and then myelinite is 50 to 70% or 50 to 90% rather na myelinite ay na matrix na, and then kapag 10% na lang or less yung iyong class porphyroplast, then that's ultramyelinite. Pag non-foliated naman, it is microbrechia or cataclysite. Okay? With cohesion pero non-foliated pa, so microbrechia or cataclysite. Cataclysite. Paano kapag again, all this suggests na wala ka pang recrystallization. If may recrystallization ka na, then that everything is just blastomyelinite. So basically, hindi mo na sure kung yung porphyroclast na tinitingnan mo ay porphyroclast ba talaga o baka naman porphyroblast na siya. Nag-grow na siya. Ganun din yung matrix. Hindi mo na alam kung ganun talaga siya ka-fine-grained or nag-recrystallize na siya konti. Uh, kaya na-reduce, kumbaga, yung dami ng matrix. So since hindi mo na siya sure, you just refer to it as a blastomyelinite. Blasto meaning newly grown. Newly grown minerals within a mine. Yan. Paano kapag puro glass yung sa matrix mo? Then that's pseudotachylite. So these are high-strained rocks. These are the names that you have to remember for high-strained rocks. It's based on texture, but also but descriptive only. So grain size reduction, but if recrystallization occurs, use blasto as a prefix. Kasi, as we mentioned before, shearing results to grain size reduction. And then pseudotachylites are thin glassy rocks formed due to extreme deformation and even melting of these ground up rocks. And this is, for example, yan, tsura ng pseudotacchylite. Basically, is para na siyang fluids spacing or filling up the spaces in between these rocks. So ito yung grade. So sa surface, usually what you have there incohesive brittle fault rocks. So the the breccias and the breccias and the gouges, fault breccias and fault gouges. But as you go deeper, and then a cohesion, and then a cohesive rocks. So cohesive rocks, you have microbreccias, cataclastites, kapag foliated na siya, the myelinites. Yeah. Okay, so in shallow areas, narrow and more brittle yung the deformation. So you have anastomosing faults, and because of that, generally walang cohesion. Below, because of the confining pressure, the deformation becomes more thorough and pervasive, resulting to finer rocks. So you end up with cataclastites, microbreccias, pseudotachylites, which are foliated rocks plus recrystallization, which can also lead to foliated rocks with some form of recrystallization, and a shear can be distributed over a wider area, more ductile, for example, resulting to more gneissic, for example, tsura. Yeah. Another special type, yung impactites nga. So impactites, medyo special siya kasi high-strain rocks siya, but you have to see these markers which suggest sudden which suggest na impact crater siya. So for example, shock crystals, amorphous glassy faces, as well as high pressure silica polymorphs like coesite and stishovite. Yeah. So, ito lang yung basically names na kailangan nyo tandaan for high strain rocks. Okay. So that's it for review ng metamorphic rocks. And then ito extra info na lang. So I want to highlight yung progressive nature ng metamorphism, metamorphic processes. So kanina or sa previous sections, I mentioned before that rocks or the metamorphic rocks usually preserve more than one sequence of metamorphism. So please always remember that a rock at now preserving a high metamorphic rate progressed through the sequence of mineral assemblage through all of the equilibrium mineral changes instead of hopping from unmetamorphosed to metamorphosed state. So although ang nakikita lang natin is yung peak metamorphic conditions, always think of it as the rock experiencing or following a PT path, a pressure temperature path, right? And in some cases, this may be evidenced by metastable relics like this actinolite, for example, surrounded by a glaucophane, surrounded by an ophacite, which clearly indicates a green schist facie, a blue schist facie, and finally an eclogite facie na polymetamorphism sa bato natin. Yon. Ito, for example, you have here a glaucophane, which is now replaced by actinolite. So the reverse process naman. This is a chemical map, chemical compositional map. I'm not sure which exactly, but it shows you different growth timings sa garnet grains. Yan. And these are symplectites. Symplectites formed in titanite. So this is the symplectite of calcium amphibole, ilmenite, and plagioclase, which reflect yung breakdown ng titanite, usually due to decreasing temperature and pressure. So all these are indications of the progressive nature of metamorphism. It does not end on the peak metamorphic conditions, or it does not start rather at the at the peak metamorphic conditions. It does not end there as well. So along the way, you can pick up the prograde PT path, and as you pull it down, you can also preserve retrograde textures like this. Ganun din yung pinapakita nito. This garnet grain, for example, from our study in the rinpolite, yung core ng garnet, which contains the high manganese concentration. It also includes low temperature phases like chloride and epidote, which are lost in the garnet rim and in the matrix surrounding matrix. So yun. That's an indication of prograde metamorphism. So progressive yung metamorphism natin from the core towards the rim, increasing in temperature. So yeah, it's important to determine, therefore, the PT path, pressure, temperature, and time path by delineating steps of metamorphism. So for example, ito, tinolite, we know that green schist started as a green schist, followed by blue schist, followed by eclogite. So you can mentally draw na dito muna siya, tapos umakyat pala yung temperature. So yun yung PT path natin. Note that retrograde actions require input of fluids, as mentioned before. As the rock cools, temperature decrease is not enough to drive the reaction. You have to have fluids to basically go back to the reaction. Yung examples ko kanina, last time na nito, for example. So yung blue schist, garnet, and ophacite transforming into this barosite, and this glaucophane naman being transformed into actinolite, all require this retrograde metamorphic processes require a input ng fluids. Okay, yeah. So a concept of PT path, usually you can just think of it as a burial versus exhumation stages. So exhumation versus burial, this kunwari dito yung starting rock natin, and then because of uplift, so kunwari dito siya, bury na siya, patungan siya ng maraming sediments, and therefore nag-start siya metamorphose banda dito, it gets piled up, the sediments gets piled up, yan siya. So heat, tumataas yung heat na na-experience niya, and until stage B, for example, due to tectonic processes na uplift siya, kunwari, subduction or compression. So compression resulting to crustal shortening. Crustal shortening also elevates the geothermal gradients. So kung taas yung geothermal gradients natin, maluluto lalo yung bato natin. At the same time, hindi lang siya burial, As soon as you have mountain building processes, you also have erosion processes. So, habang ini-erode natin siya, the overlying rock mass dito sa bato natin decreases, and slowly bumababa yung pressure natin, although yung temperature natin, because of the elevated thermal gradient, pwede siyang tumataas na tumataas. Then eventually, wala na yung rock mass sa taas. Yun natin, wala na yung rock mass sa taas. So, it becomes exhumed to the surface. Okay? So burial in regional scale usually occurs during plate convergence. Once the plate convergence stops, exhumation begins. And once you exhume the rock, you basically take out the taas, yung nakapatong overlying lithologies natin. So the energy from strain during this folding and folding are used to are used by the rocks to undergoing prograde metamorphism. But as soon as this stress is lost, then it starts to be exhumed to the surface and in this process may experience retrograde metamorphism. Okay? So ito yung nakikita natin, metamorphic field gradient, hindi yan yung actual steady state geothermal gradients. And ito yung kanina, yung simple burial na yung example. Let us look at this rock naman. So for example, tingnan natin yung PT path ng iba't ibang rocks as subduction progresses. For example, here we have this block, this white square, start siya dito. Pag nandito siya, sa surface. As it's subducted palalim, it experiences increasing temperature. So ito yung mga geothermal gradients natin. Increasing temperature, increasing pressure. So yan yung PT path niya. Pagdating dito, nag-stuck na siya sa pressure sa depth na to. Pero for example, pwede siyang maka-experience ng hotter, actually cooler natin. So as subduction progresses, magiging cooler yung ating interface. And because of the cooler interface, pero nandito pa rin siya sa depth na to, basically it follows this isobaric path. So same pressure, slightly nagiging cooler lang yung ating bato. So it experiences cooler temperatures. Ganyan. And then if that progresses, so kunwari, yung puti lang muna, iintindihin natin. So dito, it starts to be exhumed to the surface, for example. So as soon as it's exhumed to the surface, that experiences cooler temperatures and less pressure. So, ganyan. Balik. This is a counterclockwise PT path. In this case, yung peak metamorphic conditions niya is here. Yung highest or yung maximum pressure niya is also around here. Dito. Okay? Tingnan naman natin yung another rock type. Let's say black. Itong black na square naman, start siya dito. So, ganun din, pag ganyan. Pero this time, mas cooler yung geothermal gradient kasi mas developed na yung subduction. And as it goes further down, ito na yung pagdating dito sa starting point na to, it gets exhumed to the surface. So pagdating dito, na-exhume na rin siya kaagad sa surface. So as soon as it's exhumed, basically yan. So pagdating dito, exhume na siya. So it experiences cooler geothermal gradients, the same pressures, so it follows yung puti kanina. So ito, clockwise yung PT path niya. So basically, what this is suggesting is that you can have both clockwise and counterclockwise PT path, depende sa timing ng subduction ng material natin and exhumation niya. So the point is, you have to independently identify yung PT path ng rocks natin sa field. Okay? So note that rocks reach peak temperature at different times, and metamorphic field gradient is not equivalent to the geothermal gradient. So ito yung steady state geothermal gradient, ito yung MFG or metamorphic field gradient. Okay? Metamorphic field gradient, again, representing peak metamorphic conditions in a series of rocks across a metamorphic complex. Okay, so that's it. I hope you learned some things from this review. And then if may questions kayo, we'll discuss this in person. Okay.